Imagine you're building a beautiful house, but you forget to lock the doors and windows. Would you feel safe living there? That's exactly what insecure coding is like in the digital world. Every line of code you write is a potential entry point for users, yes, but also for attackers. In this lesson, you'll learn why secure coding isn't just for senior developers or cybersecurity teams. It starts with you. You'll discover simple but powerful coding practices that block common attacks, explore real-world examples of insecure code, and get introduced to tools that help you code like a defender. By the end, you won't just write code that works, you'll write code that protects. Across industries, code has become the lifeblood of digital systems, and unfortunately, it's also the most common entry point for cyber attacks. A shocking 90% of security issues happen because of avoidable coding mistakes. These aren't theoretical flaws. Attackers actively hunt for things like hard-coded passwords, weak session management, and poor input handling. Picture someone slipping through an open window because the latch wasn't secured. That's what happens when developers skip security basics. The truth is, no firewall or antivirus can protect insecure code. Your code is the first line of defense. The earlier in your journey you embrace this mindset, the more valuable you become, not just as a coder, but as a responsible builder of safe technology. Think of secure coding as your checklist before a flight takes off. These golden rules aren't just good habits, they're essential to preventing crashes before they happen. Validating input, for example, is like scanning every passenger before boarding. It stops threats at the gate. Hard-coding secrets? That's like writing your house key on the front door. Proper error handling keeps attackers from seeing your internal systems when something breaks. Using updated libraries means you're not flying with known mechanical issues. And the principle of least privilege, only giving code the access it absolutely needs, is like locking certain rooms on a plane to avoid hijacks. These practices don't slow you down. They protect your build. Master these early, and you'll save yourself and your users a world of trouble. Some of the biggest breaches started with small, avoidable mistakes, like using dangerous functions without checks or assuming that client-side validation was enough. Think of evil as handing over your house keys to a stranger who seems nice. Skipping server-side input validation is like trusting a sealed envelope just because it looks untampered. Not using HTTPS or secure headers is equivalent to shouting private data in a public room. And leaving debug tools active in production? That's like leaving your diary open on a park bench. Hackers don't need to be geniuses. They just need one unlocked door. Knowing these common traps helps you avoid them and gives you a huge advantage over developers who don't code with defense in mind. Let's see what this looks like in code. Imagine you're building a user lookup feature. The insecure version takes input directly from the URL and plugs it into a SQL query. That's like letting strangers walk into a bank vault just by guessing the right door code. A textbook SQL injection vulnerability. But in the secure version, you prepare the query and bind the value safely. This is like putting security guards at the gate who check credentials before letting anyone through. It's a simple change, but it completely shuts the door on a major attack vector. This is the power of secure thinking. A few extra steps can mean the difference between safety and disaster. Secure coding isn't just about rules, it's a mindset. It means treating every input as guilty until proven safe. It means choosing libraries and frameworks that bake in security, like Spring Security for Java or Laravel for PHP. And it means building security into your workflow, not as an afterthought, but as a habit. Think of it like brushing your teeth, not glamorous, but essential to avoid painful problems later. Whether it's static code analysis tools, peer reviews, or simply pausing to think, what could go wrong with this function? The more you build this mindset into your coding style, the stronger your software becomes. To support secure habits, developers rely on powerful tools. SonarQube helps you scan your code base for both quality and security issues, like a spell checker for bad practices. OWASP Dependency Check highlights outdated or risky libraries in your project. Python developers use Bandit to detect vulnerable code. Git hooks can block accidental pushes of sensitive credentials. And for managing secrets safely, Dotend lets you keep keys out of your source code. These tools aren't magic, they still need your judgment. But they act like safety nets, helping you avoid mistakes that slip through the cracks. Explore them, use them, and let them raise your standard of what good code really means. Ready to test your eyes for code smells? In this activity, you'll be given a short piece of vulnerable code. Your mission: spot at least 3 insecure patterns, things like unsanitized input, hard-coded credentials, or dangerous functions. Then, rewrite it using the secure practices you've just learned. Think of it like refactoring a leaky dam. Plug the holes before the flood. And if you're feeling confident, share your secure version on GitHub or with a mentor. Real growth happens when you not only learn, but apply. Let's see how you think like a defender. Secure coding isn't about being paranoid, it's about being prepared. You've just gained the mindset and techniques to write code that not only works but defends. Whether you're building web apps, mobile tools, or internal systems, this knowledge travels with you. Every developer mistake avoided, every secure habit formed, adds to your value and impact. Keep using the tools, asking the what if questions, and rewriting unsafe code when you see it. Because in a world of digital threats, your skill is not just building software, it's protecting it.